Okay, this is the third video in Chapter 6. We looked at writing the ionic formulas in the last video for ionic compounds, balancing the charges in the formulas. Now we're going to look at the opposite. If we're given a formula of an ionic compound, how do we name it? There's two different actual naming systems for naming binary, which means two different ions only. So binary ionic compounds. The first will be using something called the stock system, and the second will be using something called the classic system. The stock system and classic system exist when you have an element, like a cation, that can have more than one charge. Right now we're just going to look at binary ionic compounds, though, in which the cation and the anion can each only have one charge. So it's obvious what the charge is. So let's see here. If you have a metal and a nonmetal in a given molecular formula, remember that is how you know you have an ionic compound. You have a metal bonded to a nonmetal. And maybe you'll have X number of metal and Y number of nonmetal, like sodium chloride, calcium sulfide, lithium fluoride. So if you have a metal anywhere in your formula, by the way, you are an ionic compound. So how are we going to name these compounds? If the compound contains a cation that only has one type of charge that it can form, what are the cations like this? Well, they're metals in group 1A, 2A, because all of those group 1A and 2A metals we said can only form one charge type. In group 3A, we've got aluminum. And then remember on the periodic table, my quick drawing the periodic table, in the transition metals, there were 3 of them on the left-hand side in the transition metals that are typically known for only forming one charge. And those are zinc, cadmium, and silver. So we talked about those in the other videos. So if you have group 1A or 2A or aluminum in 3A, or zinc, cadmium, and silver, these metals only contain one charge, and you don't have to worry about designating what the charge is. It's already understood by the chemist. So if this is the case, you have an ionic compound, the metal only forms one type of cation charge or oxidation state, then you're just going to name the cation plus the anion. Remember when we named cations, it was just named the elements, and then we put the word ion on the end. For anions, remember that it was the stem of the element, and then the suffix "ide" at the end. So let's look at an example here. And I know these are a little blurry, but I'll walk you through them. The first one here that we're looking at is AlF3. AlF3. And by the way, that's not how you're going to read those by the end of this chapter. You'll actually just say the name when you read it. But what is the name of AlF3? How would we read that? Well, we see that we have a metal and we have a nonmetal. We have an aluminum and a fluorine. So we know that we have an ionic compound. There's a metal present. We have to ask ourselves, is this an ionic compound in which the metal only forms one charge? Well, aluminum is one of the metals that only forms one charge. So the answer is yes. So we're just going to name the cation and then the anion. The cation is aluminum. And the anion is fluorine. But remember, when you name the anion, you use the stem plus ide. So it'll be fluoride. So we've got cation, anion ending in ide. The name of this compound is aluminum fluoride. So you don't read AlF3, you read aluminum fluoride. Let's do a different one. The next one we have here is Ca3N2. Ca3N2. We notice that Ca is calcium, N is nitrogen. So when you evaluate, you've got a metal, you've got a nonmetal. So really what you have is a cation and an anion. This is an ionic compound. Calcium is in what group on the periodic table? Calcium is in group 2A. So calcium only has one charge. It's in group 2A on the periodic table. So we're just going to name calcium as calcium. We don't have to designate the charge. And then nitrogen is the anion, so it's not nitrogen, it's nitride. So name of this compound is calcium nitride. Let's do one more. Here we have KCl. Potassium, group 1 on the periodic table, has a +1 charge, only one charge. Chlorine, the anion, chloride, so this is potassium chloride. There you go. Okay, that seemed easy enough, right? Alright, let's move on to how we name ionic compounds if we have a metal that can form 2 or more types of cations. What do I mean by this? Well, remember I said in a previous video, and you might have read in your chapter actually, because you probably read the chapter first, that many of the transition metals, the group B metals, can have more than one stable oxidation state, or more than one stable charge that they form. So, depending on the compound that's formed, you don't know what the charge is unless you kind of figure it out. So, there are certain cations that have certain charges. There are plenty of transition metals that have multiple charges. Right now, we're just going to concentrate on learning these. So for the exam, I want you to concentrate on the iron charges, Fe, the tin charges, Sn, the copper charges, Cu, and the lead charges, Pb. We're not going to learn every single one of them, although I will say in the chart in the back of your book, you'll see all of the ions and the charges they form. So there are many of them. But if we can just memorize these 4, we can start applying the rules. So let's talk about the charges that iron forms first. Iron is Fe, and iron can form either the +2 oxidation state, so the iron 2 ion, or it can form the +3 oxidation state, the iron 3 ion. So according to the stock naming system, notice that I'm saying iron 2 and iron 3. How do I write that? The way that we write in the stock naming system is if you have an element, a cation that could possibly have more than one charge, you indicate the charge of that cation in the compound by writing the cation name and then putting the charge of the cation using Roman numerals inside of parentheses. So for example, if I have an Fe2 plus cation in my compound, I'm going to name that iron and then using Roman numerals 2. So this is the iron 2 ion. If it was the 3 plus, I would put iron 3 here. It turns out that iron has 2 stable oxidation states, +2 and +3. You're going to need to know those, so memorize them. Iron can be +2 or +3. Alright, let's move on to tin. Tin is Sn. I always remember that one, tin-SN, because it kind of sounds alike and it rolls off your tongue that way. So tin is Sn. Tin can have 2 different stable oxidation states. It can either have the +2 oxidation state, that's very stable, or tin can also have the +4, the higher oxidation state. So tin can be +2 or +4. Well, how are we going to name these ions? If I have a compound that contains a tin cation, I need to designate which cation is present in that compound. According to the stock system for naming, I'm going to call this the tin 2, and I'm going to call this the tin 4 ion. Tin 4, over and out. So, how do we write that? Well, once again, remember the stock system writes the name of the cation down and uses the Roman numerals to indicate the charge in parentheses. So if I had the Sn 2 plus, the tin 2 ion, I would literally write tin, parentheses, Roman number 2, ion. And if I have the SN4 plus ion, that's the tin4 ion, I'm going to write 4 in Roman numerals. Now remember, 4 in Roman numerals, a 5 is a V. So if you put an I before a V, you get a 4. Alright, so you're going to need to memorize this. Tin can form the +2 or the +4 ion. Remember those two. Alright, let's move on to copper. Copper can form 2 stable oxidation states, the +1 or the +2, and you're just going to have to memorize them. So if copper forms the +1 oxidation state, we're going to call this the copper 1 ion. And if copper forms the +2 oxidation state, the higher oxidation state, or charge, we're going to call this the copper 2 ion. I think that's pretty obvious now, right? Okay, so you'll need to memorize once again that copper can be +1 or +2. Okay, the last ion we're going to look at and memorize are lead. Lead is Pb, so Pb is not peanut butter and jelly, it's lead. Pb is lead. Lead can form 2 different stable ions, just like tin, it can be the +2 or the +4. Now you'll notice things like lead, that's not technically a transition metal, but it is a heavy metal. So a lot of the heavy metals, the ones further down in periods 3 and 4, will also have more than one oxidation state for stability. So what are we going to name these? If we're the Pb2 ion, we're literally going to call that the lead, Roman numeral, 2 ion. If we're the Pb +4 ion, then we're going to write down lead, parentheses, Roman numeral 4, close parentheses, ion. So that's how we would name those ions. So if you see these 4 metals in your compound, you know for sure that they are going to have, you're going to have to indicate what the oxidation state is to the person you're communicating to so that they will know which oxidation state you're referring to. Are these the only elements that have more than one oxidation state? I think I've said it before, but no. Things like chromium and mercury, there are a lot of different elements with multiple oxidation states. These are the 4 that I'm going to make you memorize for the exam, though, so we'll use them as examples. Alright, so let's practice naming some real compounds, the full ionic compounds, that contain these metals with more than one charge. The only difference is, instead of just naming the cation and anion now, we're going to indicate the charge in the Roman numerals. So let's start. The first one we're looking at here is Fe3P2. Fe3P2. Now, this is not the iron 3 cation. A lot of times someone will look at this and they'll go, oh, Fe3, that's iron 3. And they'll write iron 3 down. What does that subscript 3 indicate? And what does that subscript 2 indicate? Those indicate the amount of each ion, not their charge. Now, we're going to reverse what we did earlier. Do you remember how when we looked at the charges earlier, we did a crisscross down in order to indicate the number of atoms? What we're going to do here is we're going to reverse it. We're going to reverse the crisscross to give us the charge. Before we do that, though, we're always going to look at the anion. Because we know we have a cation here, iron, and iron can have multiple charges. So what is that charge? Well, let's figure out the total anionic charge right now. Phosphorus does not change its charge. The anions don't. And we know phosphorus is in group 5A. It has a -3 charge. So if we have 2 phosphide ions, each with a -3 charge, the total negative charge is -6. In order for this to be a neutral compound, the total positive charge also has to be +6 in order to get a net of 0. Alright? So, right now, from the formula, we know we have 3 iron cations, and the total charge is +6. So, 6 divided by 3 equals, what's the charge of each? It's going to be +2. Okay? So, here, in Fe3P2, we have the iron 2 cation. There's another way I can do this, other than thinking about the charges here. We can just reverse the crisscross like I said. If we see here, first of all, we indicate phosphorus is always -3. Do you see how this 3 matches up with the 3 up there? If the subscript of the metal matches up with the superscript of the nonmetal, you can reverse the crisscross. So this 3 will come up here, this 2 will come up here. Once again, we indicate we have the iron 2 phosphide. So I see now that I've got a +2 charge. I've got 3 iron ions. And I've got 2 phosphide ions. So when I go to write this name, remember when you write the name of the ionic compound, it's the name of the cation and the name of the anion. So this will be iron, but because iron can have multiple charges, we're going to indicate the charge now using Roman numerals. This is iron 2 +2 charge, and it's not phosphorus, it's phosphide. Iron 2 phosphide. Alright, let's do another one now. The next one we have here is CuO. CuO. We've got a copper, Cu, we've got an oxygen, O. So we know we have an ionic compound because we have a metal and a nonmetal. So when we have an ionic compound, we name it the cation and then the anion. However, we always have to ask ourselves with ionics, does this cation have more than one charge? Copper is one of the ones that we're going to memorize could have one of 2 charges. It could either be copper +1 or it could be copper +2. So when we name the compound, we have to indicate the oxidation state using Roman numerals. And right now we actually have to figure out, once again, what the oxidation state is. So what you're going to do is you're going to write out the formula again. CuO. We have one of each right now. So whatever the charge of the anion is, and oxygen's in group 6A, it's -2, must be the charge of the cation because we have one of each. So the total negative charge is -2, the total positive charge must be +2. So anytime you have one of each ion type, you know that their charges are equal and opposite. So we have a +2 charge here. Notice that the reverse crisscross won't work in this method. If you have CuO and you put the 1s there, remember the first step I said for reversing the crisscross is always to see what your charge is. The charge of the anion is -2. That will never change. When you want to reverse the crisscross, you always ask yourself, is that subscript the same as the superscript over here? Well, here the answer is no, so we cannot reverse the crisscross. But I think it's obvious whenever you have one of each, whatever the negative charge is, that's what the positive charge will be. So the oxygen's -2, so the copper is +2. So how are we going to name this then? We figured out the charge, it's the copper 2 ion. So we're going to name it copper, Roman numeral 2, oxide. Cation plus anion, but if the cation has more than one charge, indicate that charge. Alright, so this is what we do for the stock system of naming. The stock system of naming is the kind of new way to name ionic compounds to indicate the charge easily. But I will say that we have to know the classic system of naming too. This is an older type system naming that actually uses the Latin names of the metals rather than the names we usually use, that we accept nowadays. So the Latin names are a little bit different, and then we're going to take that name, we're going to modify the suffix. If we have a lesser of the charges that the metal can form, we're going to use the us suffix. And if the charge is the greater of the 2 charges, we're going to use the ic suffix with the Latin name of the metal. And so instead of the name of the metal plus the Roman numeral, we'll have the Latin name with the suffixes us. Us will be the less, ic will be the more. I always remember the suffix us as the lesser charge because I always say us is less, us is less, us is less, us is less. And that sounds very similar, us and less. I know that I'm very redundant when I say things, but that's so that it will stick in your mind. All right, so let's get started. We just said that iron can form two different cations. It can either form a +2 or a +3 to be stable. The iron +2 cation is the lesser of the two oxidation states. So we're going to take the Latin name Fer for iron. That's where we get Fe from, by the way. And Fer, we're going to put the suffix us on it to indicate the lesser charge. So the Fe2, the iron 2 ion, according to the classic system of naming, will be known as the ferrous ion. I always think it sounds pretty like a Ferris wheel. If you have the iron +3 charge, that's the greater charge, it'll be ferric. So you see how that works? All right, let's look at the tin. We know that tin can form +2 or the +4 ion. The 2 is the lower oxidation state. It's less. Tin, the base root name is stan or stain, S-T-A-N-N. So if we have the lesser, it's stan-us. If we have the greater charge, the +4, it's stan-ic. Copper, the Cu comes from the root cup, C-U-P-R. Okay, so we know that copper can form the +1 state or the +2 state. The +1 state is the lesser charge, that'll be the us, cuprous, and the +2 state is the greater charge, it will be cupric. All right, let's look at lead finally. Lead is plume. See where the PB comes from? Plume, like an old pen. So if we have the lesser charge, PB +2, then we'll be plume us. But if we have the greater of the oxidation states, the +4 for lead, it'll be plume-ic. All right. So instead of saying I am lead 2 and lead 4, you'll say plumus or plumic. So let's do some examples here real quick. The first example we're going to do is SnF2. And we're going to name this just like we did before, but we're going to use the classic system instead. So the first thing we notice is we have a metal and a non-metal, so we have an ionic compound. After you notice you have an ionic compound that you need to name, you know that's cation and anion, you're going to ask yourself, does my metal have more than one stable oxidation state? Ooh, Sn, that's 10. That's one of the metals that I said you needed to know could either have a +2 or a +4 oxidation state. So the question is going to be, which one is in this compound? Well, we're going to figure it out using math and our problem-solving skills. So the way we figure it out, once again, is we're going to write the cation down. We don't know its charge yet. It's plus something. But we do always know the charge of the anion. The charge of fluoride is -1. It's in group 7. Look on your periodic table. 7 minus 8, -1. Now notice how many fluorides we have. We have 2 fluoride ions at each -1 charge. So the total negative charge is -2. All right. If the total negative charge is -2, what must be the total positive charge? +2, because it's got to be even or 0 overall, net charge of 0. So if the net charge is +2, and we notice we only have one tin ion, then it must carry the full charge. It must be +2. So here we have the tin 2 ion. By the Roman numeral name, the stock system, it would be tin 2 fluoride. How will we name tin 2 fluoride according to the classic nomenclature system? Sn2+ is the lesser of the tin charges. Remember, tin can be +2 or +4. We have the lesser, so we have the stan-us. Us is less. So here we have the stan-us fluoride, or the tin 2 fluoride. You need to know both ways to name, and this is why the classic system is why it actually becomes important that you know what the charges should be, so that you know which one's the lesser, the greater charge. So practice doing those. I think that's pretty self-explanatory, and we'll move on to molecular compounds in the next video.